Hello. This lesson will be on application of Pythagoras theorem. So just write the title, application of Pythagoras theorem. All right. We do a number of examples and we explain how to use Pythagoras theorem. Basically what we are doing, the triangle is not given to us. We got to make our own triangle and use Pythagoras in that triangle to answer the question. Question 1, for example 1. Consider the two buildings as below. We need to connect their roofs with a cable as shown. How long is the cable? So how long the cable should be. All right, so basically we have building, so that's building 1. Then there is building 2. So let's say this be the ground level. And then we have building 2. That's building 2. Now we know their distance. So they are apart from each other by, say, a distance of 30 meters. They are apart from each other by a distance of 30 meters. This building is, say, 20 meters tall. And this building is 50 meters tall. Now what we need to do, we need to connect their roofs by a cable like this. Cable like this. That's the cable. We want to see how long that cable should be. So that's the cable. We want to see how long that cable should be. All right. As you can see, there is no right angle triangle here, but we got to make our own triangles, right angle triangle. So if this is the right angle triangle, so I just make out this right angle triangle. This is the triangle that we have. All right, this is the length of the cable. Let's call it L. This bit is basically this 30 meters. And this bit is the difference, between the height, because this is 50 and this is 20. If I draw a line like that, this triangle is this triangle. So that is from here to here is 50, from here to here is 20, so 30 is left for this bit. So that's 30 again. All right, now we can use Pythagoras to find the length. So L squared is equal to this short side squared plus the other short side squared. And that gives us L squared is equal to, that's 900 plus 900. That gives us 1800 if you add them, and then you square root it to find L. So from here, L is equal to square root of 1800, which is 42.4 to 1 decimal place. So 42.4 meters to 1 decimal place. That was example 1. Now we look at another example. You walk from your home 400 meters west, then 600 meters north. How far are you from your home? So here what you need to remember is these two directions are perpendicular to each other. So when you're walking west and then north, that will be perpendicular to each other. So if your starting point is here, for example, and you're walking west, west is to the left, all right, that's your starting position. This is your starting position. And then you move from here to here. Now you are moving from that position north. So north, that's north. Okay, we are not drawing any of this to scale. So you started here, you are here. So first you move that much west, then that much north. So that's your starting position or your home. That's your home. And this is your final position. We want to see how far you are from your home. In other words, how long is this line? How long is this line? This is straight line. This one. Again, as you can see, we have a right angle triangle here. We have a right angle triangle here because we said west and north are perpendicular. So you got 400 west, that's 400 west, and 600 north. And we want to find this. This is the hypotenuse, C. So again, C squared is equal to 600 squared plus 400 squared. That gives us C squared C squared is equal to 600 squared is 360,000 plus 400 squared is 160,000. So altogether, these two become 360,000, 520,000. Then we square root that to find C. So 520,000. That gives us 721.11 meter to 2 decimal places. All right, another example, example 3. A container is in the form of a cylinder with a height of 10 meters and a radius of 2 meters. Find the longest rod that can be stored inside the container. All right. So what we have is a cylinder here. That's the cylinder. If I want to fit a rod inside that, it's going to be like this. That's the rod, the longest one I can fit inside. All right. Again, we can make here a right angle triangle. The right angle triangle hasn't given to you, but you got to make your own right angle triangle. That is the right angle triangle that we have. That and this. This is the triangle that we have. This is the rod, and we made this triangle ourselves, which is again a right angle triangle. All right, how much is that? Remember, they said that the radius is 2. Radius is from here to the center. So that is the diameter. That becomes double the amount of radius. So it's going to be 4. And then they say the height was 10. So that's 10. Then we need to find C. That C is the hypotenuse, also is the longest rod that we can fit inside. So then C squared is equal to 4 squared plus 10 squared using Pythagoras. That gives us 16 plus 100, and that gives us 116. Now we square root that to find the longest one that we can fit. So that is 10. So C is equal to 10.77 meters to 2 decimal places. That is the longest one that you can fit to 2 decimal places. All right, that was for example 2. Now we look, that was, sorry, for example 3. For example 4, which is going to be our last one. So I'm going to have a rectangular prism. So this is going to be a three-dimensional application of um, Pythagoras theorem. All right, so basically what we are interested in, as you can see, this is a rectangular prism. We want to see how far is from this point A, how far is from this point A here to this point B. All right, so in other words, if I want to draw a line, straight line from here to here inside this shape, how long it is. All right, so that is the question I'm trying to answer. So so basically find the length of AB which connects two opposite vertices of AB, A and B of the given rectangular prism. Of course, they give us the dimensions. Say, for example, this length is, say, 15 meters. This height is, say, 6 meters. And this width is 10 meters. 10 meters, 6 meters, and 15 meters. All right, we want to see how to find that. That is going to be a bit more complicated. What we can do is this. I can as you can see, there is no right angle triangle again here. We got to make our own right angle triangle, and this time we are going to need two of them. All right, I'm drawing one. This, let's change the make it a dash line, so that, and this. Let's call this point C. This point is C. So A, B, C. So it might not look like it, but this is a right angle triangle here too. So triangle ABC is a right angle triangle. But I don't know how long. I know AC is the height, which is 6. That's fine. I'm after AB, but I don't know other short side, which is BC. So I need to find BC first. Again, if I call this corner D, that is another right angle triangle here. So triangle CDB is a right angle triangle. So our solution will look like this. In triangle BDC, let's call this X and let's call this Y. X squared is the hypotenuse. In this triangle, X is the hypotenuse. X squared is equal to a CD squared plus BD squared. Then X squared equals CD. CD is this bit, which is the same as this bit, which is 10. BD. BD is this bit, which is the same as this, which is 15. So from here, I can work out X. So that's 100, that's 225 all together. They give me 325. X is square root of 325. And that gives me 18 meters. 18.02, which is quite close to 18. So let's take it the whole number, 18 meters. So X is 18 meters. Then now I'm working on triangle ACB, this triangle. ACB, this one. This is again a right angle triangle where Y is the hypotenuse. So in triangle ABC, we have Y squared, which is the hypotenuse, is equal to this is squared, which is the same as this, which is 6. 6 squared plus this is squared, x squared, which we just found. X was that much, but I already have x squared, so I can write 325. Because x squared is 325. If you want, I can write y squared is equal to ac squared plus x squared. AC squared plus x squared, AC is 6, and x squared is 325. So that gives me y squared is equal to that 36. That is 325. Y squared is equal to 361. 361. Now I square root that to find y. That gives me 19. So 19 meters is the length of y. Okay, find the length of AB. So that basically diagonal, the largest diagonal that you can have here is AB, and it is 19 meters. That is all we have for this lesson. Thank you very much for your attention.